So you're putting -1 in here because you solve x plus 1 equals 0. Now, as you go across through there and you have your coefficients, you have a 2 on x cubed, and then we're missing x squared. So you got to put that 0 in there. And then 5 and 7. So you bring your 2 down. It's -2. Add and get -2 times -1 is 2. So that'll give me a 7, and then -7 will give me a remainder of 0. So what's...
Okay, yeah, that was right.
So that's going to represent 2x squared minus 2x plus 7. And from there, I am trying to see if that will continue to factor. So 2 times 7 gives you the 14, and you need it to multiply to 14, and it needs to add up to -2. So 14 doesn't have factors that'll do that. Okay, so that should be what's in that parenthesis set. And then we need 4 also.
Yeah, because that one I had that
Okay. So when you take 2x minus 1 and solve for x, you're going to have a 1/2 here. So we automatically don't like that because it's fraction. But you keep your coefficients. So you have a leading coefficient of 4, and then we're missing 1. And then we've got 3, and then we're missing another one, and then we have -1. So I pull this down. Half of 4 is 2. I add and get 2. Half of 2 is 1. I add and get 4. And then half of 4 is 2, so I get 2. And half of 2 is 1, so I get the 0. Did we get to there?
Yeah, I think I just went thinking because I did it like twice, and I like used my calculator and got 5 decimals.
Ah. So from there, this one is actually a little bit longer because you got 4x cubed plus 2x squared plus 4x plus 2. So that will keep going. And it first off has a GCF of 2, so I can take that out to begin with. So I have 2x cubed plus x squared plus 2x plus 1. And then from there we have 4 terms, so we group these 2 at a time. So the front 2 stays. If I look at the GCF of those 2, I'll get x squared. So 2x cubed divided by x squared will leave me a 2x. And then x squared divided by itself is a 1. And then over here we have 2x and 1 have a GCF just 1. So that'll be 2x plus 1 here. And that's where we have the twins that can be factored out. So the front 2 stays a 2. The common factor is 2x plus 1. And then we're left with x squared plus 1. So this one should have been 2x plus 1. And then an x squared plus 1. And then in general, we put the 2 out front.
That would be better once I remember.
All right, so we got x is equal to -b plus or minus square root. B squared is 2 times 2, which is 4, minus 4. And then I always recommend that kids go ahead and multiply a times c and put that number in there. That just keeps you from having to do more steps. And then you have 2 times a, which is 2 times 2, which is 4. So from there, we have -2 plus minus. So I've got 4 minus 24. So under my radical, I end up with the square root of -20. And from there, we know that we're going to have a -1. And then the perfect square that goes into 20 is the number 4. So I've got square root of 4 times the square root of 5 times the square root of -1.
I just did the -5.
So we know that the square root of 4 is the number 2. And then I'm going to go ahead and use that square root of -1 because that makes an I right here. And then I have the square root of 5. And that is divided by 4. And from here, it's up to you, whichever way you want to do it. Some kids will use the -2 and divide it by 4, plus minus, and then the 2i square root of 5 divided by 4, and you reduce those fractions. The other way to do it is to factor out the GCF in the top. You get the same answer either way. So you can also do this factoring out a -2. Actually, just make it +2. So that'll give you -1 plus or minus I square roots of 5. And then you divide that by 4. So you do this or this, not both. Whichever one makes more sense. If you like to factor, then you'll probably factor out the GCF. If not, because the bottom is just a single number, you can separate it. So regardless which way you do this, you end up with -1 plus minus I square roots of 5. And because both denominators end up being a 2, you can rewrite them back together. You don't have to, but the reason that they've given you x to the 4th and x squared is it is just the next level above the x squared and x. So for this one, they want you to solve for x squared. So it's written out the exact same way. So it's -b plus or minus. And then I've got b squared, which is -4 times -4. Go ahead and multiply that, and you get 16. And then you got -4, and then you do 1 times 2, so that gives me the 2. And then I'm dividing by 2 times a, which is 1, so that's just 2 here. So we have 4 plus or minus square root. 16 minus 8 will give me an 8 right there. And then I'm looking at working on the 8, square root of 8. So that busts down into 4 and 2. So we have the square root of 4 times the square root of 2. And don't forget your denominator. So we'll get 4 plus or minus. The square root of 4 we know is the number 2. And then the square root of 2 over 2. And again, here's where this can go and be separated or factor out the GCF. So whichever way you want to work it out, you end up with 2 plus or minus the square root of 2. Because those 2's completely go away, and that goes into that twice.
Yeah, I got the answer. I just did for that one. I can't remember.
Yeah. So if I'm getting rid of a square root, you're going to end up isolating it. Okay, so this one is already by itself, so that one's good to go. This one, you're going to have to get the square root of 2x alone. So you'd subtract 1, divide by 3. And then this one's a little bit different because it is a rational exponent, which is a radical. So if you wanted to change it into radical form, you can, but you don't have to. All right, so the next step on the first one would be to square both sides. This one, you'll end up with the square root of 2x is equal to 2. When you subtract 1, you get 6, divide it by 2 and get 2. So you'll square both of those sides as well. Now, this one squares quite easily and becomes this, and then you get x is equal to 2. That one works very fast. This one, kids are prone to not do the right side correctly. So when I square a square root, I just keep what's under it, and on this side, you have to write this down twice. You have to FOIL that out. Now, on the third one, the first thing you're going to do is get that x to the 3/4 by itself. So you're going to add 5, and then that gives me 24. Then you're going to divide by 3, and that gives me 8. So I have x to the 3/4 is equal to 8. Now, again, you can change this into a radical, but you don't have to. All right? The goal is to get the exponent on the x to a 1. So what would I need to multiply 3/4 by to make that turn into a 1? The reciprocal, right? So you could raise this to the 4/3 power. And what you do to one side, you have to do to the other. All right, if you don't like that version of it, you don't have to use it. The alternative way to do that one is to write it as the fourth root of x cubed is equal to 8. So on this one, you would raise both sides to the fourth power. So you still have the x cubed. I have no idea what 64 times 64 is. 256? No, that's not right. It's a big number. All right, this one is actually easier to do because this is x, and then I have the cube root of 8. And then I'll raise whatever that answer is to the fourth power. That one's a whole lot faster to do, not needing so much of a calculator. So the cube root of 8 is the number 2, and then you'll raise that to the fourth power. So 4 times 4 will give me 16. So you've got whichever way you're most comfortable with, and of course you are going to have a calculator, so the right side wouldn't have been difficult. I just don't have a calculator in my hand. So you can work on these whichever way you prefer. I think sometimes it's harder for kids to get all of the denominators to match, and it's easier just to get rid of the denominators. So on this first one, that one, of course, has a denominator of 1. So I need to figure out what do I need to multiply each one of those by to make that denominator go away. So what does the first one take to get rid of it? This one I would need to multiply by 2x, right? But can I multiply 2 by that and make the fraction go away? You can. Because this is 2x, and I'm multiplying that by 3 over 2x. If I multiply the next one by 2x, that'll still get rid of that. Because the 2 will cancel the 2. So that gets rid of it. Now, over here, you still have to multiply by 2x, even though the denominator is just 1. You still have to make sure that you multiply every single term by that same thing. Now the second one, I'll leave that one for you all to finish. The second one is a little more complicated because they're not just one term in each, okay? That last one has 2 terms in it. So to get rid of the first one, I would need to multiply by 3x. And just like what we just did, 3x will get rid of the 3, okay? So this one works. But now, is that going to get rid of that last denominator? No. All right, so on this last denominator, I know I've already got to multiply by the 3x because I've done that to all the other 2, but I also am going to have to multiply by x plus 6. So if I change that last one, I have to change them all. So I've got to multiply that one by those and the front one by those. And what that's going to do is make sure that all the denominators go away. The alternative, I'll just show it to you. The alternative is to make all the denominators look the same. So if I'm trying to make the first one look like the other 2, well, it's already got a 3 in it. It's got an extra x in it, but what does it not have? The x plus 6. So you'd have to multiply the first one by x plus 6. You'd have to multiply the second one by x times x plus 6. And then the last one you'd have to multiply by 3x. All right, I think clearing is easier. I think you all can see it better to be able to say, well, I got to make that go away. So when I go through, move this out of our way. All right, so if we've got 3x times x plus 6, and I'm going to multiply that by the first term, then that 3x cancels that one, so I still have my 2. And I still have x plus 6. It didn't get rid of all of what I'm multiplying by, but that part's okay. The denominator is now missing. So if I multiply the second one by that, 3x times x plus 6, then that 3 cancels that 3, and I still have the 2 that's in the numerator, and I have still x times x plus 6. All right, I had 2 things left over for that one. And then on the last one, last term, we've got on the other side, you're going to multiply by 3x times x plus 6. And you're going to multiply that by the 8 over x plus 6. So that x plus 6 cancels that one. So I'm left with the 8 that was in the original numerator, and now I've got to multiply it by what's left from what I multiplied by. So that one's a step up from the first one, and then 3 is a step up from the second one. Because in the last one, you have to look at that last denominator, and you're going to have to factor it. So the front one's going to stay just like it is for right now. Second one's going to stay just like it is for right now. And in that last one, I'm going to have to factor the bottom. So what does the bottom factor into? Good. X plus 1, x minus 1. So that's the one I need to match everything else up to. So what's missing in the first one that I need to be in the first one, or excuse me, we're not doing that. Sorry. You're clearing fractions. So the thing that's going to take the most to make it clear is this last one. I'm going to have to multiply this term by x plus 1, x minus 1. Well, if I multiply this one by x plus 1, x minus 1, is that going to take care of my denominator? It will, because this is going to cancel that, and I'm good. All right, this cancels both of those, so I'm good. And if I multiply this one by x plus 1, x minus 1, does it also get rid of it?
Yes.
Yes. So for this one, we have our 2 left, and then only x minus 1. In the second term, we have the x is still there, and we still have x plus 1. And then on the right-hand side, only the numerator remains. So clearing fractions makes your life a whole lot easier. So we have f of x is equal to negative x squared plus x. And what we are asked to do is find out what f of 0 is. So I'm plugging that in right there for that x. I'm also going to plug it right there for that x and right there for that x. Now f of 0 is very much a problem with being a little boring, because if it's all zeros, then there's not a whole lot happening. But we know that f of 0 then would be negative. We plug the 0 in where the x is, and then we square it. And then we have another x, so we plug that 0 in where that x is also. So if I square 0, I still have 0. Negative 0 is not a unique thing. It's just 0. And then 0 plus 0 is what? Just 0. So f of 0 is 0. Now, so for that one, you're given a number for x, you substitute it in. Well, what happens in number 2? If I do f of x equals 0, then that's telling me that I have y is equal to 0. So if I started with f of x is equal to negative x squared plus x, so you're still starting with that same one in this question. And this time, I'm going to be solving to put f of x is 0. So I'm plugging that in for that. It's not going in for x this time, but it's going in for y. So I have 0 is equal to negative x squared plus x. Most children do not appreciate that it's backwards, okay? So we rewrite it. We have negative x squared plus x equals 0. Anytime I have something that has a degree bigger than 1, the leading coefficient has to be positive. So how do I make that into a positive? You can multiply or divide by negative 1 all the way through. So I think most of you all will do this. If you do it the other way, that's fine too. All right, so we have x squared, and then x divided by negative 1 is negative x, and then 0 divided by anything is still just 0. So to solve that, I need to factor. what's my GCF? X. And then I have remaining x minus 1. So then we have two factors in parentheses. I set each one equal to 0 and solve for x. So that one has two answers. When x is 0, I get a y that's 0, which is the ordered pair point 0, 0. And also when x is 1, then I get a y value of 0, which is the ordered pair point 1, 0. Okay, so f of negative 1/3, I'll leave that one for you all to do. So the next one is another function, and it's asking you similar, all right? This one, you're going to plug that in for the x in the original equation. The second one, you're going to plug the 1/8 in for the y, or the f of x, just like we did in the second one up above it. Now the fourth one, number 4 on this page, is asking for the zeros. All right, so what this is meaning is that it wants you to find the x-intercepts. So the way you find any x-intercept is to let y be equal to 0 and solve for x. So that is asking for the zeros or where the line crosses the x-axis. So the next one is kind of talking about your parent graphs. I'll let you all kind of look at that before I'm not going to go over those just yet. So if we look at 16, these are more function operations. So this is composition. So this first one is wanting us to take the g of x function and plug it in first. So the f stays, and then g of x is replaced with 3 minus 4x. You can put it in descending order would be best, so negative 4x plus 3. Just flip the thing around. And now this f in the front tells me that now I've got to go over to this one. It skips. It skips to the other function that you're given. So into that, we are going to put this expression. So that's going to go into the f of x function where the x is. So it's going to go right there. So we have the front two. And then we have x, which we are substituting in for the shaded red, so negative 4x plus 3. And then you can't forget the exponent. So f of x is 2x squared, and our x is more complicated. It's negative 4x plus 3. So then you write that down twice and multiply it out all the way. So FOIL those two, or distribute the two into one of them and then multiply. Now for the next one, you're doing exactly that backwards. So you're going to take the f of x and plug it in first. So I keep my g, and then instead of the f of x, we're going to put 2x squared in there. Then we've got this has to go into the other function where the x is. So we have 3 minus 4 times 2x squared. And if you switch the order, you're fine. So this will give me negative 8x squared, and then I still have positive 3. In general, when you're doing those back and forth, depending on what you start with, one's going to be a little easier than the other. So 3 is a little easier. It's just f of x minus g of x. The thing kids have trouble with on this one is that the negative sign has to be distributed. That's what we forget to do. So f of x is 2x squared. G of x is parenthesis 3 minus 4x. And then you have to distribute. So this one always trips kids out just a little bit because you got 2 f's back to back. That just means that you're only working with one of the functions. So I'm going to write the function up here. F of x is equal to 2x squared because I've written all over it up there. So I'm going to substitute that in for the red. The function f of x is equal to 2x squared. And now I have to do f of 2x squared. So that means I'm going to take 2x squared, and this is going to be plugged in where that x is. So 5 and 6 kind of go together. All right, you'll have to finish that one, but 5 and 6 go together. You're working with the g of x function. So for this one, you do exactly what we just did. All right, g of x is negative 4x plus 3. We're going to plug that in first, and then plug it back in to the same function. So you have g of negative 4x plus 3. And then that's going to go in where the x is. Same function, and it's going to go in right there. So I have negative 4x plus 3. And this is what I'm plugging in for the x value. So negative 4x plus 3. So we distribute the 4, and then we'll add 3 to the answer. So we have 16x minus 12 plus 3. So we have 16x minus 9. And that is the final answer for g of x. And the reason I write it that way is because that's what this one says, number 6. So you're going to take g of x, substitute in what we got, and set it equal to 0. So for transformations, you need to look over those. We can cover these 6 tomorrow if anybody has questions. I know you learn these at different times and with different teachers, so I'll wait and see what questions we have on that one. When we go to the next one, you are choosing smart points. So by smart, what they mean is, for this first one, it's nice to know that I can choose wisely and end up with numbers I can graph easily. All right, so we default sometimes to -1, 0, and 1. Okay, -1's a good one. All right, so if I put -1 in there, that's going to be the square root of 3 minus, and then if I'm subtracting a negative, what am I really doing? Adding. All right, so that's the square root of 4. Well, what is the square root of 4? Just 2. All right, so that will be the ordered pair point, -1, 2. So that's a smart point. Now, if I put 0 in there, I'm going to end up with the square root of what? 3, which is a big long decimal. That's not going to help me. All right, if I put a 1 in there, is that going to help me? What's 3 minus 1? 2, and the square root of 2 is a big long decimal. All right, those are not smart points. They are still on the graph, but they are not smart points. Okay, so what happens if I put a 3 in there? 3 would give me 3 minus 3, which is 0, right? And what is the square root of 0? 0. Okay. Now, when they're doing this, they're trying to help you figure out maybe those transformations you're not real comfortable using them, because you can graph that very quickly with transformations. But sometimes you all just want to make sure that you've got actual ordered pair points. And there's going to be times in the class where we have to use actual ordered pair points to find things. So you do want to choose wisely if you can, all right, the smart points. So what would the next smart point be? If I go bigger, what happens under that radical? If I put a 4 in there, what's 3 minus 4? -1. Can I take the square root of -1 and graph it? No, that's not going to help me. So going bigger on my domain values, the x values, is not going to help. I have to go the other way. So if I did -2, that would be 3 minus a -2. So 3 plus 2, 5. Square root of 5 won't work. So what's the next perfect square past 5? Nine comes first, okay? So if I want this to turn into a 9, then I would need to have 3 minus a negative, what number? 6, good. So I would have had to put a -6 in there, okay? So sometimes you're working from the y value that you need and going back to figure out what domain makes it work, all right? Now, in number 2, what is a number that's not going to be good to use? What do we not want down there? I don't want a 0 in the bottom, right? So what number makes a 0 in the bottom? All right, so when x equals 2, we have a vertical asymptote. Now, we will be reviewing that, okay? So if that's kind of maybe not sounding like something that you remember off the top of your head, we will look at this more. But I don't want to put a 2 in there. So beyond knowing that at +2, we have a domain issue, I also am going to want to find numbers that will go into 7 nicely, okay? So what else do we have? So what number is going to go into 7 most easily? If this was 7 divided by 7, I'd be really happy, right? Okay, so what would make a 7 in the bottom? A 9. Okay, so that would be the ordered pair point 9, 1. All right, now the tricky thing with 7 is it's not got a lot of factors anyway. All right, so -7. What would make a -7 down there? -5. Okay, and that'll give me the ordered pair point -5, -1. Now this is saying that you should choose 3 of them. If you know where the vertical asymptote is, then 2 points would be enough. All right, and again, we're going to spend a whole section on rational equations. So if that's making you a little nervous, don't let it. All right. For this last one, we want, if you look at your exponent, it is x over 4. So wise things to choose would be things that 4 will divide into. All right, so give me a number that 4 will divide into. 8 would work. 4 would work, right? 0 would work. 0 divided by 4 is just 0. So there's 3. I could also use -4 and -8. All right, you don't have to do that many, but if you have 3, and then if I'm doing 8 divided by 4, well, what is 8 divided by 4? 2. So that's 3 squared, which is the ordered pair point 8, 9. Then if I do 4, so I've got 4 divided by 4 gives me an exponent of 1, which is just 3. If you use 0 divided by 4, that's just 0. And 3 raised to the 0, anything, any base raised to the 0 power is the number 1. Those would be the 3 smart points I would use. We default to looking at some negatives, but you're going to get fractions for these, which is fine also. But these might not be the ones that help you the most. So I got 3 to the negative first. So that gives me 1/3. And then 3 to the negative 8 divided by 4 is -2. And that's 1/3 squared, which is 1/9. Now it's very hard on your online work to graph fractions like that. That's going to be difficult. So the top 3 would be your smartest points. So for distance, you've got one formula, and for the midpoint, you've got a second one. So distance is d equals square root. And then you take the difference in the x's and square it, difference in the y's and square it, and add that together. So x, I always do x2 first. You can do either one as long as they both go in the same direction. And then to find the midpoint, that's asking you for the middle between the 2 ordered pair points. It also is an ordered pair point. You do x1 plus x2 over 2. So you're halving it. And then y1 plus y2 over 2. The biggest thing I see kids struggle with on this is when you have fractions and you all are used to having that Desmos calculator. You've got to make sure that you're careful with the division, with the adding and the division. So I'll leave that one for you all to look at. All right, intercepts. So again, I've already talked about an x-intercept. I'll write it again here. X-intercept, you're going to let your y value be equal to 0, and you're going to solve for the x value. And then for the y-intercept, that's when it hits the y-axis, it's exactly the opposite. So you're going to let x be equal to 0 and solve for y. Some of these, depending on if you have squareds, and I think all of those, I don't know about the last one. Yep, all those have squareds in them. So you're probably going to end up factoring for at least one side of it, the x-intercept or the y-intercept. You'll be factoring or taking square roots depending on what's going on. And a note to say here is when you take a square root, your answer has to be plus and minus. So if you had the square root of 1 in your problem that you had to physically take the square root of 1, the answer would be plus 1 and minus 1. How are we with lines, equations of lines? Are we remembering all the forms we need? So standard form, slope-intercept form, point-slope form. So which one do you work with the most from Algebra 1 up? Do what? Slope-intercept?
Yeah.
All right, you all use y equals mx plus b. Now, that's great as long as you have a slope and a y-intercept. All right? If you don't have a slope and a y-intercept, you can use that equation, but the one that you might want to use more is y minus y1 equals your slope, x minus x1. So for that one, you need a slope and a y-intercept, or excuse me, a slope and an ordered pair point. Now, standard form is one that you're not going to see a whole lot. We don't ask you for standard all that much. We've about stopped teaching it altogether in Algebra 1, but it's your x comes first, your y comes second on the same side, and then you have anything constant over here. So the way they write it is ax plus by equals c. And the kicker with this is a has to be positive and a cannot be a fraction. So 23 is the Pythagorean theorem. This has been around since middle school, all right? Now, I don't say a squared plus b squared equals c squared. This is the way this is labeled, so it's a true statement depending. Now, if I look at this, this doesn't give me a squared plus b squared equals c squared because this is a leg and this is a leg. What's the other side called? Yep, hypotenuse. Okay. So this one is not a squared plus b squared equals c squared. This one is a squared plus c squared equals b squared. So you can't automatically assume that you're going to do them in alphabetical order. This one will not do that. So each one of those things that it's asking you for in those three questions, you will be using that equation. And then 24 is not a topic, it's just something to read through because these are the things that kids tend to want to do from algebra problems that don't work. So I'll answer questions on anything we have tomorrow. I'll move the quiz that we're going to have over this to Wednesday. We'll just do that on Wednesday.